Hey guys, Mr. Klein here, and here we are with our next lesson on changes in matter. This will be a lesson that the video will be a little bit long, but at the same time we're going to sit on this lesson for over a week of class because this is really important stuff in science and I want to make sure you know it. So this is like the baseline information that we're going to use. We're going to do a bunch of experiments and lab demonstrations for you guys to understand. So let's go ahead and let's get going. Now, in our last lesson, we talked about how matter can be measured and classified by its chemical or physical properties. Physical properties being stuff we can observe. Chemical properties are when we have chemical reactions. Well, what are chemical reactions and what are physical reactions? In other words, what are physical and chemical changes? Well, let's just dive right in and let's say that a physical change is when altering the form of any substance of matter, but it does not. Physical changes alters or changes the form of appearance of matter, but does not turn any substance into matter into another substance. Okay? In other words, a substance that undergoes a physical change is still the same substance after the change. Now, a good example of this is when snow melts or changes state. Okay? When snow changes state from solid snow to liquid water. So remember, when matter changes state, like from a solid to a liquid or from a liquid to a gas, it is an example of a physical change. Okay? So, matter changing state is one example, and the other is when you change its shape or its form. Like, for example, you dissolve sugar in water. And I'm going to show some examples in a second, so just hang on right here. We dissolve sugar in water. You can test to see if there's a physical change by pouring sugar solution into the pan and then letting the water boil out. Once the water has evaporated, the sugar will remain as a crust on the bottom of the pan. You don't believe me? Well, let's look at these examples. First off, I want you to ask your question. The question to ask if you see something, is it a physical or chemical change, is this in small print where you can barely see. Is it still blank after the change? If it's still it's a physical change. If it isn't, it's a chemical change. So let's look at this. Here we go. We have a water drop from an icicle. Okay, as we can see right here, the water drop's falling. Here's the icicle. So this is a solid, this is a liquid. Is this a physical change? Well, let me ask you this. Is it still water? Okay, is this icicle water? Yes. Is this water droplet water? Yes. Well, then it is a physical change because our icicle's frozen, it's water. The liquid droplet is also water. So that's for the first one where we talk about changing states of matter. But the other one, when you change the shape or form, is like this. For example, we have a saltwater solution and we have a saltwater solution after evaporation. So we have a saltwater solution in a cup right here. Here's what's left after the salt, after water's been evaporated. Here's my question for you. Is it still salt? Okay. Is it still salt? Yes, because we have salt and we have water. And after evaporation, the water is evaporated. It's turned from, we have a change in state. It's gone from a liquid to a gas, and the solid salt is left over. So is the salt in that saltwater solution a physical change? Yes, it is, because it's salt before and it's salt after. So remember, is it still blank? That's what you ask yourself. If it is, it's a physical change. The answer is no, then it's a chemical change. Now, other examples of physical changes are things like bending, crushing, breaking, and chopping matter. Things getting stuff out of solutions like filtration and distillation, also called physical changes. Okay, so anytime you separate a mixture, you separate a solution, what you have left over is a physical change. So what happens when the answer is no, it's not still that? Well, that's a chemical change. Okay, it's a change in a substance that produces new substances. We call that a chemical change right here. Okay, a change in substances that produces one or more new substances is a chemical change. And another name for that is a chemical reaction. Now, a natural chemical change you may know from biology is what we call photosynthesis, where several compounds combine with energy from the sun to produce new substances. And so here I have this diagram right here of Photosynthesis. Okay, sunlight comes from the sun. We have in the flowers and in the leaves, carbon dioxide goes in along with water. We have a chemical reaction, oxygen comes out. So carbon dioxide goes in, we have a change. Is it still carbon dioxide? No, it's changed to oxygen. So if the answer is no, it's a chemical change. And there are four major types of chemical changes. We're going to look at some cool examples of each right here. So there's four examples that we need to know. The first one is combustion. Combustion is when fuel combines with oxygen to produce heat, light, and new substances. You know, explosions, fires, stuff like that. Whenever you do something like this, an ethanol gets lit up through an electric charge. That is a chemical change. Okay, so combustion is the first one. The second one is electrolysis. And electrolysis is where we apply electricity, and it's used to break a compound into elements or to new compounds. The most common example of which is this with water, where we can put two pencils with a 9 to 12 volt battery in it and some salt or some acid, and hydrogen and oxygen break up. And I'm going to do a class demonstration later this year with an electrolysis machine, and you're going to see the hydrogen and oxygen get separated from that. So we're using electrolysis to break this apart. This is water. Electrolysis happens. Is this still water? Is this water? Is this water? No, it's H2 and it's O2. That's two separate things, therefore it's a chemical change. The next one is oxidation. Oxidation is a combination of oxygen and another substance. And the easiest example and the most common example we have of oxidation, and there's whole sorts of types of oxidizing reactions we could go into, and you will when you take chemistry in high school, is this: rust. Rust on iron. An oxidation reaction happens with water. Water and iron come together and they form rust. And so the question is this rust on there? Is it still iron? Is it still water? No, it's something different. Therefore, it is a chemical change. Finally, tarnishing. Tarnishing is a slow combination of a bright metal with sulfur to produce a dark coating on the metal. And if you and your family, you might have some fancy dishware or something like that, and over time it starts looking like this, all stained and stuff. This is what we call tarnishing, and this is how it would normally look in silver, but the sulfur is reacted to form this covering. It's kind of like rusting, but it involves different elements, so it's a little bit different. Now, you might be saying to yourself, Mr. Klein, so you showed an example earlier with salt water, and the water evaporated. Well, the salt's still there. Isn't that a change? Well, no, actually it isn't. Water may seem to disappear when it evaporates, but remember, the water is still water. So that's a physical change. But water evaporating is an interesting concept that we need to talk about with chemical changes. So water may seem to disappear, but science has proven that it does not. In fact, it just changes form. So after a famous experiment measuring chemical changes, scientists discovered that the mass or the amount of matter in a substance did not change both before and after the chemical reaction. And this is really important right here, so I need you to pay close attention. The fact that matter or mass is neither created nor destroyed in a reaction, it's always equal on both sides, is what we call the scientific law of the conservation of mass. The law of conservation of mass. That matter is neither created nor destroyed in a chemical change. It just changes shape and stuff like that. And here's a good graphic organizer to look at. Before the reaction, we have a certain amount of mass. They're equal. After the reaction, it's still the same. Okay? Before and after the chemical reaction, it's still the same with the law of conservation of mass. And the matter is still the same no matter what. And we'll get into this a little bit more. We'll talk about balancing equations. You can see that for yourself. But right now, just remember this. When you have a chemical reaction, everything that's in there is still the same. Okay? And we'll do a lab demonstration where you can see the law of conservation of mass in action to where you can understand. So let's head into the home stretch of our notes. And we have this, is how is energy and mass related? Well, changes in matter require energy, or the ability to do work or cause change. Okay, and we'll talk a lot about energy when we talk about physics of motion and things moving and things like that with mechanics. But essentially, energy is the ability to do work or cause change. And this change we're talking about is a chemical reaction. But every physical and chemical change in matter includes a change of energy somehow or some way. Now, like matter, like we just talked about, there's a law of conservation of matter. Well, there's a law of conservation of energy. So that means that energy is conserved in a chemical change. It can only be transformed. It can change from one type to another. It can go from chemical to physical energy, or in this example, we're about to talk about thermal energy or heat. Okay? So keep that in mind. No matter what, energy, mass, we have a chemical reaction, or even we have a physical change, there is no loss of matter or energy. It just changes from one thing to another. Okay, and the amount remains the same. Now, we know that temperature is the measure of how hot or cold something is. And this will come into energy in terms of chemical reactions. We'll talk about two of them in a second. Temperature is, yeah, how hot or cold it is, but how do we know, how do we generate heat and stuff? Well, temperature is related to the energy of the motion of the particles of matter. In other words, the particles of gas in a warm air has higher average energy than the energy of the cooler air. In other words, the molecules are bouncing around faster at higher temperatures than they do at lower temperatures. And we'll look into that when we look at changes of state in matter. So just understand that warmer temperature, atoms are bouncing against each other even more than they would be when they're colder. And the type of energy having to do with temperature is thermal energy. Thermal energy is the total energy of all particles in an object. So in other words, if we count up all the energy of all the atoms in an object, that total energy is what we call thermal energy. And that sounds really fancy and you might be confused. Let me put it easier for you. Heat. Heat is the total energy of all the particles in an object. That's what we measure as heat. So the warmer something is, the higher temperature it is, the higher the energy of all the particles have. Okay? Temperature and thermal energy aren't always the same things, but like temperature is just like a state of a current state of the object, but thermal energy is kind of its total heat stored in there. But thermal energy moves from warmer matter to cooler matter. Heat always moves from high to low. Just like gravity pulls something downhill, heat goes from high temperature to low temperature. And thermal energy is often released or absorbed when matter changes. For example, so you take some ice and you put it out, and it's starting to melt. So what's happening to the temperature? Well, it's going up. But where's it getting the heat from? Well, the heat's coming from the outside. Because if you put your hand right by the ice, it gets real cold. That air's right there. And that's because ice is absorbing thermal energy, making the surrounding area feel cooler. So that cooler air is that warm temperature moving into the lower temperature area, the high thermal energy into the lower thermal energy area. And we see this in changes of energy, especially in chemical reactions. So there's two. Okay? And the change in energy, where energy is absorbed, like for example, we have ice melting, or even a chemical reaction, is what we call an endothermic change. Endo means inside, thermic means has to do with heat. And the melting of ice is a good example of that. Or we have a chemical reaction right here. So you know, like the cold packs, like if you grab it, you break it, and it gets cool, you can put it on an injury. Well, that's an endothermic chemical reaction. So what happens is when you break it, the chemical reaction goes on the inside, and it starts sucking in heat from the outside. And as we just talked about, with ice, that the warmer air is moving into the cooler air for the ice to absorb in order to melt. And that's what's happening right here, is that the heat from the warmer air is moving in right here, and that movement allows the temperature to drop and causing an endothermic reaction. Now, the other way, when energy isn't absorbed but pushed out, is what we call an exothermic reaction. Okay? Where energy is released is an exothermic change. Exo meaning outside, thermic meaning having to do with heat. And of course, combustion is an example of thermal energy and light. And we have this example right here. We have a chemical reaction. This is a thermite reaction. We have the chemical reaction going on, and heat is just flying out. Heat's being pushed out from here. It's going off, because what ends up happening is once this reaction's done, this will cool down. And I do realize I put in a typo right here, that where energy is released, not exothermic, but where energy is released, it's an exothermic reaction. Now, one last thing about energy and matter being related is that atoms are held together from the last lesson with chemical bonds. And the energy held in chemical bonds is what we call chemical energy. And chemical energy can be stored in food, fuels, and even the cells in your body, like fat cells. Fat cells are full of chemical energy. They have complex molecules and stuff that hold them together. And so when our body needs energy, it burns fat cells. And when you burn fuel, chemical energy is released as thermal energy, or as heat. And you might not realize it, but your body gives off thermal energy in chemical reactions whenever you run around and you play. Because when you do that, you get all hot and sweaty. And so that's a chemical reaction of your body running around and getting the heat being generated because you're burning off all those fat cells, the energy, the chemical energy stored in the fat cells, and you sweat. So that change from chemical energy to thermal energy is an exothermic reaction. So it's a lot of information. I know. 16 minutes in length is this video. It's really long, but I wanted to make sure we did a lot of examples for us to understand that there's physical changes and chemical changes. And if you ask yourself that you see a change, is it still blank? If it's still that, physical change. If it's still that, if it's still water, in this example, it's a physical change because it hasn't changed into another substance. On the other hand, if we have an example like this for photosynthesis, where is it still carbon dioxide after photosynthesis? If the answer is no, it's a chemical change. And there's 4 types of chemical changes. There's combustion, where heat and light are given off. There's electrolysis, where we use electricity to break down molecules. There is oxidation, where oxygen combines with things in order to have chemical reactions. And then there's tarnishing, where we have sulfur combining to make chemical changes. And the law of conservation of mass or matter is that when you have a chemical reaction, the amount of matter before the reaction is the same as it is after. And the same goes for energy. And energy is needed in order for a physical or chemical change to take place. And the main type of energy that we think of is thermal energy, the amount of energy the particles in an object has. And we like to call that heat. And there's 2 types of changes. There's endothermic, where the temperature drops because heat's being absorbed, and then there's exothermic, where heat is given off, like an explosion or a fire or something like that. So there you go. Lots of information. We'll have a quiz on this, and we will spend a very long time in class and do a lot of demonstrations where you guys can understand that. So if you have any questions, please let me know, and thanks for watching.